Hey, this is Mr. C, and this is Unit 1, Lesson 2, Ready, Set, Go. This first set of questions here says use the coordinate grid to find the length of each side of the triangles provided. Give answers in exact form. Now on the triangles, these are all right triangles, the vertical and horizontal sides are pretty easy to figure out. We just count up the various units. So on number 1, for example, this is 1, 2, 3, 4, 5, 6, 7. And the horizontal is 1, 2, 3, 4. And we don't know what the diagonal is, the hypotenuse. But we can use Pythagorean theorem. So remember Pythagorean theorem, a squared plus b squared equals c squared, where c is always the hypotenuse. So if we plug that in for number 1, we're going to have 7 squared plus 4 squared equals x squared. Now 7 squared is 49. 4 squared is 16. And then when we add those together, that gives us 65. Take the square root of both sides. And we get our answer as x is equal to the square root of 65, which we're going to leave. We're not going to approximate that because it says give the answers in exact form, which means leave it as a radical. Okay, number 2, same thing. The horizontal side that we have here, that is 5. The vertical is 1, 2, 3, 4, 5, 6, 7. And we need to find the hypotenuse, which is x. Okay, so we'll set up Pythagorean theorem. So 7 squared plus 5 squared equals x squared. 7 squared is 49. 5 squared is 25 equals x squared. 49 plus 25, that is going to be equal to 74. And we take the square root of both sides, and we get x is equal to the square root of 74. Okay. Number 3. This one's a little tricky because we only have one horizontal side at the bottom. That is 4. So really what we're going to have to do is notice that if we split this down the middle, we get an isosceles triangle. Actually, this is going to be 2 isosceles triangles, where this is 2 and this is 2. And if we plug that into Pythagorean theorem and this triangle on the left here, we end up with 2 squared plus 2 squared equals x squared. And 2 squared is 4. And we still have x squared, so 4 plus 4 is 8. Take the square root of both sides, and we get x is equal to the square root of 8, which is true for both sides. Okay, number 4. Our horizontal length 1, 2, 3, 4, 5, 8. And the vertical is 2. Gotta find the hypotenuse. So 8 squared plus 2 squared equals x squared. 8 squared is 64. 2 squared is 4 equals x squared. 64 plus 4, that is 68. Take the square root of both sides. And x equals the square root of 68. Okay. All right. Moving on to the set. Graph a line that is parallel to the given line, and then write the equation for both the original line and the new line. So we can really pick any point on the grid as long as it's not on our original line. So maybe like right, well, let's do like right down there. Okay. Now the original line has a slope of up 2 over 1. So that is the slope of the original line. And the y-intercept is -2. So the original given line, our equation would be y equals 2x minus 2. Now, in order for it to be parallel, we're going to need to use the same slope. So we're going to have to go up 2 over 1, up 2 over 1. And then we can connect our dots. And there is our parallel line. One of a whole bunch of different solutions that we could use. Really just depended on where I put my first original point. So the equation of my new line, well, I can see I have a y-intercept of +3. So my slope is going to be the same. It's still going to be 2x. But my y-intercept is 3. All right, same thing for number 6. We're going to plot some starting point, maybe right there. Okay, we'll check the slope of our original line. Looks like it goes down 1 over 4. So the slope is -1 over 4. And the original y-intercept is 4, so the equation is going to be y equals -1/4 x plus 4. Now if I start my new line here, it really doesn't matter where I start it, as long as it's not on the original line. It's going to have that same slope. So down 1 over 4. And I can backtrack that to get another point. We'll graph that with a straight edge. Okay, there's our parallel line. And our equation is going to be y equals same slope, -1/4 x, but my new y-intercept looks like it is at 1. Okay. Number 7, another parallel line. Again, just picking a random spot to graph maybe go down here. I'll put a y-intercept down there. Okay, our slope of our original line looks like it's down 4 over 1, so the slope is equal to negative 4 over 1, or just negative 4. Our new line's going to have that same slope, so working backwards to go down 4 over 1. There's a couple of points. Okay, line up my straight edge and connect those dots. Oops, not too good. A little better. There we go. Okay, there's our parallel line, and that one, the original line would have an equation y equals negative 4x. There's the y-intercept at 1. My new line, my parallel line, this one has the same slope, but I picked a different y-intercept that's at negative 4. Okay. Perpendicular. Now when we do perpendicular lines, the slopes are opposite reciprocals. Opposite reciprocal slopes. So my original line, there's my y-intercept at 1, and my slope goes up 1 over 3. So my equation of my original line is going to be y equals 1/3 x plus 1. All right, for my new line, I can pick any point, anywhere really. Maybe pick that point right there, just randomly. My slope has to be the opposite reciprocal, so I need to take this slope and flip it and change the sign, so from positive to negative. So now my new slope is negative 3 over 1 or negative 3. So from this point, I would go down 3 over 1. Down 3 over 1. Down 3 over 1. Okay. Take my ruler, line it up. Okay, and we can see we're getting that nice 90-degree intersection from that perpendicular line. And the equation for that is going to be y equals our new slope, so negative 3x. And my y-intercept, just got it on this graph here, it's down here at negative 6. Okay. Some more perpendicular lines. So the original equation, here's our y-intercept at negative 1. The slope looks like it's going down 4 over 1. So negative 4 over 1, or negative 4. So the equation of my given line is y equals negative 4x minus 1. The new slope, I've got to flip that upside down, that fraction, and change the sign. So it was negative, now it is positive. So I just have to pick a new point. Let's start with a point on the y-axis to make it easier for to write our equation. So maybe like right here at 3. Okay. So now my new slope is down 1 over 4. I'm sorry, not down 1, up 1 over 4. Up 1 over 4. Okay, so there's a couple of points. We can graph our perpendicular line. There we go. And this would be an equation of y equals 1/4 x. And the y-intercept there in this case is 3. Okay. Again, graph a line that is perpendicular to the given line. So, our original line, there's our y-intercept. Looks like it's got a slope of positive 2 over 1. Or 2. Y-intercept is negative 2. So my equation would be y equals 2x minus 2. The equation of the new line. We'll pick another point. Let's do something over here maybe. All right. Maybe right here. Okay, my new slope. If my original slope was 2 over 1, my new slope needs to be negative 1/2. So down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. We can take our straight edge, graph our line. Okay. So y equals negative 1/2 x. And then our y-intercept right there is 3. Okay. On the next page, we are just graphing these equations. They are in the form of point slope form, so y minus y1 parentheses equals, well, we don't need parentheses for that one, equals m parentheses x minus x1. So the key to this is recognizing what is your slope and where is your point. And in number 11, we see our y1 and x1 coordinates. So the coordinates of that point is, we know the y coordinate is going to be 5 because it's minus the y coordinate. And the x coordinate is going to be negative 2. Why is it negative 2? It's a negative because of that plus right there, because in our equation, it's x minus x1, so x minus minus 2 is going to change that minus to a plus. So the shortcut way of thinking this is it's always the opposite sign of those coordinates. Okay, so we'll plot that point, -2, 5, right there. And then we use our slope. So there's our slope of 1/2, so up 1/2. Just get enough points. Put our straight edge down and graph that line. Okay. Moving on, number 12. Our point is going to be -1 on the x and -3 for the y, always that opposite sign. And then our slope is -2. So we'll plot that point, -1, -3, there it is. And then we're going to use that slope, -2, so down 2/1, down 2/1. Just get enough points. There we go. That's probably enough to get my straight edge in there. There's our line. Okay. Number 13. Yep. Point of -6 and -3. -6 and -3. And our slope is +4. So we'll go up 4/1, up 4/1, up 4/1. We'll graph that line. Okay. Number 14, there's a typo here. It should be a slope of -23. We're going to get rid of that 3 and just make it a slope of -2. That'd be a very steep slope for us to graph. It'd be almost vertical, almost. Well, not quite vertical, but still pretty high there. Okay. So let's plot our point, which is going to be at +6 and +5. So 6, 5, and our slope is -2, so we'll go down 2/1, down 2/1, down 2/1. Go ahead and plot that. There we go. All right. Number 15, 16 says write the point slope equation, a line given between the 2 points, and then graph the equation. So point slope, remember we need a point and a slope. Well, we have 2 points. We're going to have to figure out what the slope is. So real quick to do that. There's our x and y. If we just put our points here, I can see in my y, I'm going down 4, and in my x, from 3 to -2, that is down 5. So my slope would be -4/-5, or having a negative over negative, that will equal +4/5. So So that is our slope. From there, we just pick one of the 2 points. Doesn't matter which one, 3, 5, negative 2, 1. We'll just pick A. So the equation I'm going to write, if I pick that point, is y minus 5 equals the slope. My slope. 4/5 parentheses x minus 3. Okay, so now I'm ready to graph that. So we go to 3, 5. There's 3, 5. And then our slope is down, or sorry, up 4 over 5. Up 4 over 5. There we go, that should be enough. Okay. Number 16, same thing. Gotta figure out what our slope is. So x and y, negative 5, or negative 1, 5, and negative 2, 2. On this one, our y coordinate is going down by 3, and our x coordinate is going down by 1. So the slope is going to be equal to negative 3 over negative 1, which comes out to be just positive 3. So negative divided by negative is positive. All right, then we pick a point. I'm just going to pick A again. Doesn't matter which point you pick to plug into the equation. So y minus 5 equals the slope 3x, and this is going to be a plus 1 because it's always minus a minus is going to turn into a plus. Okay. All right, let's graph that. So negative 1, 5 is there. This has a slope of positive 3, so up 3 over 1. There we go. Okay, number 17. Same process. X and y. Negative 2, 7. Negative 2, 5. And my change in y is going down 2. And weird, our x has a change in 0. So this would be negative 2 over 0, or an undefined slope. Well, this is going to make sense when I actually graph these 2 points. So negative 2, 5 is right here, and negative 2, 7 is right there, and this is going to graph to be a vertical line, like so. And we don't use point slope for that. We're going to write this out as a vertical line equation, which is just going to be x equals 2. Oops, I put those in the wrong spot. That's negative 2. Let's fix that. Sorry. Negative 2, 7, and negative 2, 5. Just saw that. Sorry, x should be equal to negative 2 as our equation. Okay. Number 18. Let's figure out what our slope is. So negative 5, 2, 3, negative 2, so our y is going down by 4. Our x is going up by 8. So my slope is going to be equal to negative 4 over 8, which we can simplify to negative 1/2. Okay, pick a point, let's do b this time. So y minus, actually it's going to be y plus 2 equal to negative 1/2 x minus 3. And there's our equation. Let's go ahead and graph that. So 3, 2, or 3, negative 2 is right here. And we have a slope of negative 1/2. Oops. There we go. All right. One way you can check if you have done this correctly is you can look at, oh, that line is not very good. I was just about to, let's try and line that up a little bit better. Just to show you, is going to illustrate that if we graph our line correctly, it should go through both of our points. So there's 3, negative 2, and then our other point, negative 5, 2, is right there. So our line does in fact go through both of our points A and B. Okay, that takes us to our go, which is we're going to be solving some equations for some variables here, okay? Number 19, first thing that we're going to do, we're going to go ahead and distribute that 3. So we get 3x minus 6 equals 5x plus 8. From here, there are several options to collect our like terms. I'm going to start with the x's, and I'm going to subtract 3x from both sides. So that we get negative 6 equals 2x plus 8. We'll subtract 8 from both sides. So now I have negative 14 equal to 2x. We'll divide both sides by 2. And we get negative 7 equals x. Okay. Number 20. Nothing to distribute, so let's just go ahead and collect our like terms. I'm going to move that n from the left side to the right side, so subtract n, those cancel out. And we end up with negative 3 equals 5n plus 22. I'm going to subtract 22 from both sides. So now we have negative 25 equals 5n. Divide by 5 on both sides, which gives us negative 5 equals n. Okay. Number 21 gets a little bit complicated because we have more than one variable in the equation, and we're told to solve for x. So really, it's going to be the same process. We're still going to get that variable by itself. We're just going, we're not going to have a number solution. We're going to have a different equation. Okay? So, first thing that I would do Well, we could distribute. Don't have to. There's another way we could do this, but I'm going to go ahead and distribute because we're used to that. So we get y minus 5 equals mx minus 2m. Okay. Our goal, remember, always get x by itself. So next thing I'm going to do is I'm going to add 2m to both sides. Get rid of that thing. Okay. And over here I can't add m to either of these terms, so on the left I'm going to have y minus 5 plus a 2m is equal to mx. Okay. Lastly, I need to divide by m, so everything gets divided by m. So these m's cancel out, and actually also these m's get canceled out, and the rest of them just stay divided by m. So our equation, we got x by itself, and then over here we have a y divided by m, and we have a minus 5 divided by m, and a plus 2. Okay. Ax plus by equals c. Solve for y. So again, we're just going to get y by itself. So first thing that I'm going to do, let's subtract that ax on both sides. So now I've got by equals c minus ax. Last, I got to divide everything by b. Those cancel out, and we end up with y equals c divided by b minus ax divided by b. Okay. 23, we've got a proportion. So if I have a fraction equal to a fraction, the shortcut to solving that is to cross multiply. So I do 6 times 7 equal to 9 times x minus 1. Okay, and then we solve for x. So 6 times 7 is 42. Distribute that 9, so we have 9x minus 9. We're going to add 9 to both sides, so that we get 51 equal to 9x. And we'll divide both sides by 9, so we get x is equal to 51 over 9, which we can actually simplify if we divide 51 and 9 are both divisible by 3. So 51 divided by 3 is 17, and 9 divided by 3 is 3. Okay. Number 24, same thing, we're going to cross multiply. So we get 8 times r minus 9 equals 5 times r plus 5. Okay, we'll go ahead and distribute on both sides. So 8 times r is 8r, 8 times 9, or negative 9 would be minus 72, 5 times r is 5r, 5 times 5 is 25. Okay. I'm going to subtract 5r from both sides to collect the r's. So now we have 3r minus 72 equals 25. Go ahead and add 72 to both sides. So then we get 3r equal to 97. And we'll divide by 3 on both sides. And 97 divided by 3 does not simplify, so we're just going to keep that as a fraction. So r equals 97 over 3. Okay, last problem. Let's start by distributing. So 12 times 2k and 12 times 11. So multiply those out. So we get 24k plus 132 equals 24k plus 144. And then my next step usually is to collect my variables. So I'm going to subtract 24k from both sides, and I immediately have a problem. All my variables have disappeared, and what I have left is 132 equal to 144, which is a false statement, which means that there are no solutions. Okay. So if you are solving a problem and your variables disappear, you check and see what do you have left over. If it is a false statement, there are no solutions. If it is a true statement, like 5 equals 5 or 0 equals 0, what that means is that you have infinite solutions. Okay. All right, that is the end of this Ready, Set, Go.